This interactive tool predicts the subordinate mineral abundance in a sample, based on the sample's grain density. Input areas are marked by yellow background color, and results have green background. The order of data insertion is marked by letter labels in the lower left corner of the input frames. In frame A, we select the subordinate mineral present in the sample. Let's select anhydrite. In frame B, we select the matrix mineral. Let's select dolomite. In frame C, we enter the sample's grain density. This is usually derived from conventional core analysis. Let us enter 2.87. Frames D and E are optional. In frame D, we have the option to enter up to 3 user-defined subordinate minerals and their associated grain densities. We can, for example, add a subordinate mineral that we call, let's say, call it my mineral. And we will give it a density of 3.45. This mineral is now included in the list of available subordinate minerals, and we could have chosen this as our subordinate mineral. However, we will keep anhydrite in our example. Some minerals and lithologies may have variable densities. In frame E, we have the option to modify these densities within the range of published densities. In frame F, we can control the display of the results. The default is user-defined. User-defined displays the following results. In the upper results frame, we see a suggested matrix mineral, which is based on the entered grain density. The suggestion becomes progressively more unreliable as the subordinate mineral content increases, although other factors also are important. In the middle results frame, we see the selected matrix mineral, which in this case is dolomite. In the lower results frame, we see the selected subordinate mineral, and we see its mineral abundance, in this case 23%. If the entered mineral cannot explain the grain density, then this will be displayed in the results. We can, for example, change the grain density to, let's say, S2. The results frame concludes that this mineral combination cannot explain the grain density of the sample, and the tool proposes that the matrix mineral may be bituminous coal. Let us switch back to a grain density of 2.87. If we select all possible radio button in frame F, then we get a list of all possible subordinate minerals and their respective abundances. Those with no numbers are not compatible with the measured grain density. We see that the user-defined mineral that we called my mineral is included in the list. The mineral densities applied in the model are based on published values. We can display these by hovering the cursor over the black mineral density box in the top of the screen. That completes the instructions on the subordinate mineral abundance prediction tool.